Hello, welcome to ANS Solver. This is the fifth question of the paper. So as you can see, they have given us an equation of a curve with a positive constant a, okay? And we need to show that there's only one point on the curve at which the tangent is parallel to the x-axis and find the y-coordinate of this point. So what we basically need to do is, here parallel to the x-axis basically means your gradient, okay, is equal to 0, because parallel to the x-axis basically means your line is something like this. Okay, it's a straight line and the equation is something like y equals to something. Okay, it's a straight line basically parallel to the x-axis, so gradient has to be 0. So now what I do is I differentiate this. If you see, the differentiation for this is something called as implicit differentiation. Okay, because it's simple, there are two different letters, easiest way to identify. Okay, so now here I use something called as a product rule. So I take my u as 2x square, I take my v as y, so I take my u dash as 4x, which is the differentiation of 2x square, and I take my v dash as dy by dx. Basically the differentiation of y is 1, and whenever we differentiate y, I multiply a dy by dx. Okay, now I know the formula is simply uv dash plus vu dash. So uv dash is simply 2x square dy by dx plus vu dash is simply 4xy. In the same way, I can differentiate this. So I can take my u as x, I can take my v as y square, so I can take my u dash as 1 and I take my v dash as 2y into dy by dx, because whenever there's a y, I multiply dy by dx. So now I'll use uv dash, which is simply 2xy dy by dx, plus vu dash, which is simply y square. And I know the differentiation for a cube, which is a constant, is 0. So now I can write this as 2x square dy by dx plus 4xy minus, because of the negative here, minus 2xy dy by dx plus y square is equal to 0. So now this can be written as 2x square dy by dx plus 4xy minus 2xy dy by dx minus y square equals to 0. Okay, so now what I basically need to do is I'll keep 2x square dy by dx minus 2xy dy by dx here, which is equal to simply y square minus 4xy. So I can simply take dy by dx common with 2x square minus 2xy, which is equal to y square minus 4xy. Okay, so now this can be written as dy by dx is equal to y square minus 4xy over 2x square minus 2xy. So this is basically my dy by dx. But I told you, if the thing is parallel to the x-axis, my gradient is 0. So I can simply equate this to 0 equals to y square minus 4xy over 2x square minus 2xy. So simply my denominator will go away because it will be multiplied by 0. So I get y square minus 4xy equals to 0. So now I can take y common here to get y minus 4x equals to 0. So I have y equals to 0 and y minus 4x equals to 0, which gives me my y as 4x. Now I told you the graph will look something like this. So I know your y coordinate here is not 0, obviously, because it's your origin is somewhere here. So you can simply eliminate this. Okay, now I have y equals to 4x, but I need the y coordinate of the point. So what I'll do is, my equation is simply 2x square y, I'll just copy it, minus xy cube, sorry, xy square, I think, sorry, yeah, xy square equals to a cube, correct? This is what we got here, the equation of the curve. So now what I need to do is, I need my y coordinate. So in the place of y, I'll substitute 4x. So I'll get 2x square into 4x minus x into 4x square equals to a cube. So 2 into 4 I know is 8, x cube minus x into 16x square equals to a cube. So I can write this as 8x cube minus 16x cube equals to a cube. So I can take 8, basically I can write this as minus 8x cube equals to a cube. Okay, this basically can be written as x cube equals to a cube over minus 8, which gives me my x as the cube root of a cube over minus 8. So the cube root of a cube will be a over the cube root of minus 8 is minus 2. So now I need the y coordinate. So I know y is equal to 4x. So I can simply equate, I can substitute in the place of x, I can put, simple a over minus 2. Okay, so now I can cut 2 ones out, 2's are, which will give me my y as minus 2a, which is basically the answer of the question. Okay.